These are the notes for Algebra 2, Section 8.5. In this section, we're adding and subtracting rational expressions. We've already simplified rational expressions, and we've already multiplied and divided them. Now we're going to look at adding and subtracting. It should come as no surprise that adding and subtracting rational expressions is pretty much the same as adding and subtracting regular fractions. Of course, it adds a little bit of a hiccup because we aren't looking at regular fractions, we're looking at expressions, which kind of increases the amount of work we have to do. But it's still the same basic idea. Let's start with adding and subtracting if we have common denominators, like denominators. In order to add or subtract rational expressions that have the same denominator, we have to add or subtract their numerators. Right? If the denominators are already the same, we add and subtract the numerators, and then we put them over the common denominator. So in this case, we have a over c plus b over c. See, they have the same denominator, that's common denominator. So we add a plus b over the common denominator. That's how we add fractions, and that's how we've always added fractions. The same with subtraction. Common denominator, we have a minus b over the common denominator c. So the same basic idea is going to apply here. If we look at example 1, I have 9 over 6x plus 2 over 6x. I simply add the two numerators and put them over the common denominator. So this would equal 9 plus 2 over 6x, which of course equals 11 over 6x. At this point, I would need to simplify if possible. So once I've got it added, I have to simplify if it's possible to simplify. Remember, I always need to give fractions in simplest terms. So we add them together, put them over the common denominator, and simplify if we're able to simplify. Now let's look at the more difficult process. Adding, subtracting with common denominators is pretty easy. But what if we don't have a common denominator? What if we have unlike denominators? Well, there's a process involved here. In order to add or subtract the rational expressions, if the denominators are not the same, first we have to find the least common denominator. Another name for the least common denominator is the least common multiple. Alright, that's the smallest number that both of them share, the smallest multiple that both of the terms share. So for instance, the least common multiple between 3 and 4 would be 12, because you can multiply 3 by something to get 12, and you can multiply 4 by something to get 12. So that's the least common multiple. Now, once we know what the least common denominator is, we want to rewrite each expression using the least common denominator, and then add or subtract for like denominators, because we will have gotten the like denominators. So for instance, in our example here, we notice that we have two separate denominators. The least common denominator between c and d would be cd. Right? C times d is cd. So we make that our least common denominator. In order to make c into cd, we have to multiply it by d. In order to make d into cd, we have to multiply it by c. Once we've done that, we add together our pieces, just like we did before. And we get a times d plus b times c over cd. For subtraction, it's the same basic thing. Find that least common denominator, multiply to get the least common denominator on both sides, then we subtract the numerators and put them over the common denominator. Now, it should come as no surprise, obviously, that the bulk of the trouble with adding and subtracting rational expressions is in the finding the least common denominator and getting the least common denominator in place. Once we've done that, it's pretty easy, but getting to that point is where all the work is. So let's see how this works. We're going to do this in pieces. We're looking at example 2. Example 2 asks us to add 5 over 4x squared plus x plus 1 over 2x squared plus 4x. Now, in order to find the LCD, the least common denominator, we want to factor each denominator. So that should be our first thing. We factor our denominators. Now, 4x squared is 4x squared. 2x squared plus 4x equals 2x times x plus 2. That's factored. Now, 4x squared, don't need that, equals 2x times 2x. Right, so we factor everything completely. That means we get it all broken down 100%. Right, so 4x squared equals 2x times 2x, and 2x squared equals 2x times x plus 2. That means that my least common denominator is 2x, because both of these guys have one 2x in them. Another 2x, because they both have another 2x in them. Or one of them has another 2x in them. And x plus 2. Notice what I've done here. I had two 2x's, and I had an x plus 2. Two 2x's and an x plus 2. So, our least common multiple then, 2x times 2x is 4x squared times x plus 2. That's our least common denominator, lowest common denominator. We broke it down into individual pieces, 2x times 2x here, 2x times x plus 2 here. Since I had two 2x's, I put two 2x's in my least common denominator. Since I had an x plus 2 here, I put an x plus 2 in there. Notice that this x plus 2 doesn't make a third one in my least common denominator. All right, I only look for the highest amount. All right, now we know our lowest common denominator is 4x squared times x plus 2. That's what I'm going to use. Make a note, my LCD is 4x squared times x plus 2. I need to know that because I'm going to be using it. All right, so here what I want to do is write my factored version here. I've factored everything as per usual because I need to know what I multiply both of my terms by to get the lowest common denominator. For instance, 4x squared, I need to multiply by x plus 2 because I want 4x squared times x plus 2. Right. This needs to show up in all of my denominators. Now, of course, if I multiply the bottom by x plus 2, I have to multiply the top by x plus 2. Over here, I had 2x times x plus 2. In order to get 4x squared times x plus 2, I need to multiply top and bottom by 2x. 2x times 2x is 4x squared times x plus 2. So my next step then is to do all of this multiplication. I'm going to start with my denominators because I already know what they should be. On top, I have 5 times x plus 2. Right, 5 times x plus 2. And I have x plus 1 times 2x. You know what? I'm going to rewrite that because I like to have my single x terms in front. So 2x times x plus 1. Now, that's my next step. I do all of my multiplying here. We're multiplying just like usual. My next step would be to actually add my two fractions together. So that's what I'm going to do now. I'm going to add my two fractions together. 5 times x plus 2 is 5x plus 10 plus 2x times x plus 1 is 2x squared plus 2x. And all of that is over my common denominator. Right? I just did distribution. Right? I had to distribute all of my stuff and then add it all together. Now I combine like terms. To get myself a final answer. I have 2x squared plus 7x plus 10 over 4x squared times x plus 2. Now at this point, I would need to simplify by factoring and then seeing if anything cancels out. But I can tell you right now that nothing would cancel out because 2x squared plus 7x plus 10 is not factorable. 2 times 10 is 20, and there are no factors of 20 that add up to 7.